Yeah, we got this. So, drinking and thinking, occasionally tinkling. Let's talk some science. I liked that wink you put in there. That was good.
You're welcome.
I've been trying to learn how to wink. One of my friends was...
You don't know how to wink?
Well, like, I can't do it without screwing up my face or without, like, double blinking. So it's really hard. I can't...
Double blinking?
I can't
double
get it.
winking, aka blinking?
Wait, yeah. Double winking is blinking. In blinkception right there.
I guess so. Well, I'm Eric Zhuang. I personally think that wintergreen lifesavers are the best ones. Peppermint just doesn't hold a candle to wintergreen.
I'm so confused because in your considerations of the best lifesaver, you didn't even consider fruit-flavored ones, which are obviously superior.
Are they going to save your life? I don't think so. Wintergreen, mate. I said I had a story about these, and I do.
Okay, yeah.
I have a bowl of mints on my desk. It's like a fishbowl of mints, and I loaded up with wintergreen mints, and they're for my students and everything like that. Everybody who wants to come by and grab one of those is welcome to. But we had an event where somebody had left over a big bag of the peppermint ones. And we had just bags of candy sitting on my desk. Well, some sadistic bastard took the peppermint ones that look the same. They don't have any different markings. They took the peppermint ones and mixed it in with my fucking wintergreen mints. And I went to get a wintergreen mint, and I put it in my mouth, and I was like, and I spit it out, and I was like, what? Who did this? And I grabbed another one, thinking, and I smelled it too. I was like, this smells like wintergreen. And I put it in my mouth, and it was peppermint. I spit it out. I just left that day without a mint. That's all.
I mean, you're so picky because you even smelled the thing and admitted it smelled like wintergreen. They're pretty similar.
No, I think that they've just been stewing in wintergreen, you know.
Oh.
You know.
I got you, the fumes.
Ness.
See, and here's where I was talking about fruit because when I think of lifesavers, I think of the gummies. I never really had the hard ones, and by the time I did, I was already a man and wanted gummies instead. So I really like chewy gummies. Lifesavers, chewy gummies.
That's fair.
Anyway, I'm David Rutz, and I clean the sinks in public bathrooms.
How do you do that?
With paper towels and the
towels?
water available. I just don't like messy countertops. Pet peeve of mine. It's really it. No big story.
You do you.
Just, yeah.
You do you. Well, we're both here, and this is Gin and Jargon.
Welcome.
Where inebriation and discovery go hand in hand.
We've got 2 goals tonight. One is to learn something, and the second is to get drunk.
Hooray. We're here tonight at my place.
Your place.
We just decided to do, I don't know why, we just decided to do a night in.
Eric lives here.
Yeah, I do.
Yeah. And, we try to support our local breweries. We really like touring around to different bars and different breweries in town. So I made sure that when preparing the beer for tonight, I got all local beer. All of the beer we have tonight is from breweries in Ohio.
Excellent. So what's yours? What do you got there?
I have the Phoenix Brewing Company's Black Aggie Russian Imperial Stout because I love stouts, and if it's Imperial, all the better.
Where's Phoenix from?
Mansfield, Ohio,
Mansfield,
I believe.
okay,
Yeah.
Sure.
But one thing I didn't know is what the hell is a Black Aggie?
Yeah.
And it's apparently that was the nickname for some death statue over a famous person's grave, but it's also the name for people from what school, did you say?
Well, Aggies are people from Texas A&M, but they're not Black Aggies.
Oh, that sounds racist.
What, Aggies
If
or
we
Black
call them Black Aggies.
Yeah, that's right.
That sounds bad.
I mean, I guess you could be a Black Aggie. Like you could be a Black Ohioan or a Black
A
Buckeye.
death statue over a famous guy's grave, like Agnes. I think his name was Agnes.
Oh, okay.
Felix Agnes. Yes, that was it. I don't know who it is.
We could look that one up because I don't know what the hell an Aggie is.
Yeah.
But I've got Wolf's Ridge Brewing Company Gold Standards Helles Lager. It's a pretty much, I said, straight down the middle lager.
It's a lager. Yeah.
Yeah.
And Wolf's Bridge is from where?
It's from Columbus.
Yeah, it's
Right, I don't know
downtown.
exactly where okay, yeah.
Yeah.
It's good. And I like the bottle. Check that out.
It is a fancy ass bottle.
Very Great Gatsby-esque. But I'm almost finished with it, so I'm about to get up and get another one.
Yeah, I did have a bigger bottle. So I've still got a little ways to go on my Imperial Stout.
That's true.
One thing I really like about Wolf's Ridge is they have great food, too.
Oh, yeah?
Have you ever been down there?
No.
You should go try it out. That's
I
the
will.
place I've had the best steak tartare.
I think the best steak tartare I ever had was at Hyde Park.
Oh,
At one time.
So the only
We
time I've
sang
been to
there.
Hyde Park was when we sang there.
Yeah, they had steak tartare there.
I didn't have it.
I had the tuna carpaccio, too.
It was gone by the time I got to the
That's
food.
because I ate it all. I ate all that goddamn tuna. Yeah.
Like raw ahi tuna is wonderful.
Dude.
Great.
Dude. I used to be I mean, I still do love salmon, but I used to be all about salmon, but there's just no denying the goodness that is tuna.
You know, an interesting
So
thing
good.
about salmon is that in Japan, where we usually think of sushi coming from, they refuse to make sushi out of salmon because the salmon that lives in that region is infected with a bunch of parasites. So the salmon that you get in sushi is typically from the Nordic region of the ocean, like around Sweden.
The North Atlantic.
Yeah, because the salmon up there aren't infected with the stuff that's down in Japan. So when salmon first came to Japan as a sushi, people refused to eat it.
Yeah.
Like even still today, people in Japan don't really go for raw salmon because it's just not something they do, not something they're used to. But it's such a staple in America because we love our salmon. And
Did you know
it's delicious.
that? Did you know that avocado in sushi is a direct result of food shortage, fish shortage?
Oh, really?
Because avocado and fatty tuna have the same sort of
Oh, yeah.
it's a good substitute for the kind of fat content that you get in fatty tuna.
Yeah.
But when you don't have fatty tuna because it gets overfished or whatever, or it's too expensive because it's rare or it's overfished,
Yeah.
use avocado in its place.
Oh, that's pretty crazy.
or
I didn't know that.
as an additive to when you don't have enough of it.
This is trivia, and it's not even trivia time.
I know. We'll take a quick cut real quick because I'm going to go get some beer.
Yeah, get another one. Avocado. It makes sense, and I like avocado. But you know, avocados are native to like South America, right? Central and South America.
Yeah.
So it makes sense that they're an additive instead of an original.
Yeah. I love this band.
Yeah, me too.
Who doesn't love the Killers? Hot Fuzz is like one of those albums that's just like, to me, it's like perfect. There's like no, I mean, there's obviously some songs that are better than others, but like across the album, I don't think there's one song that I'm like, that I really dislike.
So the one album I can say the same thing about is Radius by Alan Stone.
Oh, I haven't listened to that one.
It's so good. Came out last spring. It's just every single song in there is great. There are a couple that I think are a little redundant and a little slow and not very creative, considering Alan Stone's like vocal capabilities. But it's just a great album all
His
around.
first album was good too. Alan Stone, just self-titled.
Yeah.
God, it's such a good album.
I've enjoyed all of his albums, to be honest.
Yeah. Maroon 5 back in the day, songs about Jane.
Oh,
That
yeah,
was
that's
hard to do,
another
too.
good one. See, okay, so I had an ex who hated Maroon 5. And I didn't get it because I thought Maroon 5 was pretty groovy. And one time I tried to play Maroon 5's Woman during sex, and she just like laughed and had to stop because she fucking hated Maroon 5. And I mean, I didn't know at the time. It's not like I was trying to ruin the sex, but it happened.
Let's move on. Well, hey, just to throw a shout out, this is Rheingeist. Rheingeist is down in Cincinnati. Oh, this is Cincy Made.
Cincy Made.
Andromeda Pale Ale. I've had this one before. It's really good.
And it's the Andromeda Pale Ale, you'll notice.
Cheeky.
I really planned out the beers we had tonight.
Nice.
So tell me, why is it appropriate that Andromeda is the name of the beer tonight?
Well, you want to jump straight to that? Because I got a couple other items to talk about. Do you have any other news items?
Okay. No, I'm just gonna go for.
You're gonna go straight
I'm gonna
for
go
it?
for the gold.
Okay, I'll just throw it out there. I just had one thing because it just came up, and I'll consider it science. It's computer science. Computer science.
Yeah, computer science.
Did you hear about the WikiLeaks CIA hack?
Oh yeah, it's not. I mean, hack. You know,
The leak,
release.
yeah. Long story short, turns out that not all, but a lot of like the encryption that we think that we have, the security that we think we have on our personal devices is kind of not.
It's all there to aid the CIA in keeping track of anyone they want to. Yeah, I mean,
essentially they have a way in, right?
Yeah.
But now we'll move on to our other more relevant topic.
And one thing, oh man, I'm getting political here. One thing that you got to realize about this release from WikiLeaks is, it's pretty aptly timed. And WikiLeaks in the past 2 years has been very not anti-American, but releasing mostly anti-American sentiment portfolios. So it's one thing to consider when considering the content of WikiLeaks.
Yeah. Yeah. It's all about validity there, though, too.
It's true. Yeah.
So you gotta suss that out. But we have other stuff as it relates to Andromeda.
Indeed. So on February 22nd, NASA announced that they had found 7 Earth-sized rocky planets orbiting a dwarf star nearby. And, Andromeda's not nearby. It's the closest galaxy, but we're talking about way closer than that. We're talking about a star in our own galaxy called TRAPPIST-1.
It's about 40 light years away.
39 and a half, which is important to my calculations.
Okay.
Because I'm very concerned about how fast we can get there. Which is around 800,000 years, so, don't worry about it.
We just need that warp drive, whoever's working on one.
We do. Like, if Starship Enterprise could become a real thing, or, not even Enterprise, any of them, it'd be great. Though, Stephen Hawking, has supported a theory for nanoprobes that could travel up to 20% the speed of light, which is pretty cool. Those could get us there pretty quick, but the problem is, those are still just theory.
Yeah.
And they require very, very directed bursts of energy. I don't really know the science or the math into it. It sounds cool. I really want it to be real so that we can explore this place. But I'm getting ahead of myself.
Yeah, for now we're just looking from afar, but...
Yeah, why? Why is this place so exciting? It's because these 7 Earth-sized rocky planets all have the capability to hold liquid water.
Right.
Which is key to life as we know it. In fact, 3 of the planets in the 7-planet system are in the habitable zone of the star, which is defined basically as a place where you can have liquid water constantly.
Yeah, I actually just read something. It was just a bit of a blur, so I don't know how substantiated it is, but they think that one of the another one might be within the habitable zone, a 4th.
Nice.
Yeah.
Yeah. Excellent.
Yeah, but that's pretty exciting. There's a couple of interesting things about. Before we get into it, how about a quick introduction of what an exoplanet is? It's pretty simple.
Absolutely.
An exoplanet, it's short for extrasolar planet, and that just basically means a planet that is orbiting a star besides our own. So any planet out there, whether or not it's rocky or habitable or anything like that, if it orbits another star, that's an exoplanet.
Yeah.
We've been finding these things over a long time, ever since really astronomy's been
so actually very recent in terms of exoplanets, just because they're so hard to see, and we'll get into that later.
Yeah.
But the first confirmed detection of an exoplanet wasn't until 1992.
Right. I mean, the last couple of years, since 2005, 2009, something like that, the amount that we've seen has just exploded.
We found one in the 90s, and we're like, oh shit, let's get all of them. So we've been searching.
To date, we've got 3,537. That's the number I have.
Oh, I got 3,586.
What kind? Oh, okay, 86.
Yeah. So we've got about 3,500 or 600 exoplanets out there.
Yeah. But these are just planets that we can just be like, yeah, that's a planet.
Yeah.
So, but that's what an exoplanet is. So, back to TRAPPIST-1. Did we mention that was called TRAPPIST-1?
Yes. Okay. Well, I said TRAPPIST-1 early on.
So TRAPPIST-1 is the star?
TRAPPIST-1 is officially the star.
Right.
Yeah.
Okay. That would be TRAPPIST-1A.
Technically, yeah.
Okay, so TRAPPIST-1 is the name of the star that these planets are orbiting around. There's a lot of really interesting things about this system.
It is.
Yeah.
Like, so one of the things, TRAPPIST-1 is what's considered an ultra-cool dwarf star, which means it's a late-age star that's going to be there for long, long-ass time. It'll still exist long after our sun has exploded. But that means that it's not releasing nearly as much heat as our star. It's not nearly as big as our star
got
either.
about 5 billion years to make it to TRAPPIST-1.
Yeah, exactly. So this star, and we'll get into this in another episode when we talk about stars.
Yeah.
But
sure.
This star is just like slightly larger than the size of Jupiter.
Right.
And, I should know how much larger the sun is than Jupiter, but it's significantly larger, many times larger than Jupiter. So this is a smaller star.
Good word. Yeah.
Yeah.
It's huge.
It's huge. So
astronomical.
This star is relatively small and relatively cool. It's not burning as bright, which means it doesn't release as much energy. So what that means for the habitable zone, where liquid water can be, you've got to be a lot closer to the star than we are to the sun.
Right.
So that means that these 7 planets that all have the potential to have liquid water are really close together and really close to their star.
Yeah, actually, they are closer to their star than Mercury is to ours.
Really?
All 7 planets could fit within Mercury's orbit.
Holy crap, that's awesome.
And they're close, really close together. So close, in fact, that I read on the NASA press release that if you were standing on one of the planets, you could see another one, and you could see another one, but you could see the one. Yeah, you could see another one, but you could see like geological formations and cloud formations.
Oh, holy crap! Oh, how cool would that be?
I know. Yeah,
damn!
Imagine being on LSD on TRAPPIST-C or something like that. But
I mean, imagine being on LSD in what 2 or 4 billion years when our galaxy collides with Andromeda. That would be pretty sweet.
Yeah.
Instead of seeing just one line of Milky Way galaxy in the sky, you also see Andromeda in the sky.
Yeah. So yeah, there's anything else about
TRAPPIST-1?
Yeah. This is the it's a record-setting system. It's the most number of planets we've found in one system.
And the most number of habitable planets we've found in one system. Potentially habitable planets. Habitable zone planets.
Habitable zone
system,
planets, yeah.
This is enormous.
Yeah, definitely.
So one thing I want to mention is that while it would take us 800,000 years to get to TRAPPIST-1, if we had Star Trek level technology...
How fast is Warp 9.5, huh?
Warp 9.5, that's exact... wait, 9.5? I'm just thinking Warp 9.
Warp 9, okay.
I've only seen Voyager. So, like, in Voyager, they make it to Warp 10, but that's all
like real
fucked up.
shaky, right? Yeah.
But Warp 9 is, like, 1,500 times the speed of light. And so it would take them about 10 days to get from here to TRAPPIST-1.
Oh, that's like the perfect amount. That's the perfect amount of time for like one episode.
Yeah, right?
On ship, you know?
Yeah.
Like one of those ones like day in the life of episodes. Those are the best episodes of Star Trek, let's be honest.
So, we just need to get to Warp 9.
How exactly do the warp factors work? Is it logarithmic?
That's a great question. When I looked this up, I was really just looking up the math for that. So I didn't look at what...
Warp 9 is how many times the speed of light?
1,500 times the speed of light.
So it's... Yeah, I don't know. Because Warp 1 is the speed of light, isn't it?
Technically, yeah.
So
Warp 1 should be the speed of light, I think.
I'm not sure.
Wait, so let's see. Star Trek, the original series. So Warp 1 is the speed of light. Yeah.
Okay.
Yeah, exactly. So like Warp 2 is 8 times the speed of light. Warp 3 is 27 times the speed of light. This looks like logarithmic. What am I missing here?
Close.
Yeah, it's weird.
It would be 1, 10, 100, 1,000.
Yeah.
Anyway, that's besides the point. One more thing I wanted to say about TRAPPIST-1 before we move on. Another kind of interesting thing about this, I don't know if you read this, but they think that it's probable that the planets are tidally locked to their orbits, which means that only like one side of the planet faces the sun.
Some
at all
of them
times.
are, yeah, that's what they think, yeah.
And so one side is always daylight, one side is always nighttime, so it must be really interesting for the weather there.
Yeah, if they have atmospheres, of course, which is something we haven't confirmed yet.
Right.
That's something that's coming up. They're launching a new telescope in the next 2 years called the James something telescope.
Oh, okay.
But it's supposed to be able to detect the atmospheres themselves. It's going to be able to detect like oxygen, hydrogen, and a couple other elements in the atmospheres of those planets, potentially. So TRAPPIST-1, why is it called TRAPPIST?
Oh, right, yeah. You know what we could have also done here? I don't know if anybody in Ohio also makes any Trappist beers, but...
Trappist beers?
Trappist beers?
Oh, beers, yeah. Oh, you're right. Oh my gosh, I didn't even think of that.
We knew it was coming.
All this planning for the beer, and I didn't even think of a Trappist ale. Ah.
Yeah.
I screwed this one up.
What exactly is this? It's so Trappist ales, Trappist beers are beers made in the style of the Trappist monks in Belgium? Belgium?
Yeah. You know, it is Belgium. I was looking at some Belgian ales at the place where I bought these beers and thought, you know, that's not quite a lager. I'll pass it over.
Well, it's a good thing because I don't really like Belgian style beers.
Okay,
Sorry,
I was
Belgium.
pretty sure you told me that before because I love Belgians.
I don't like them. They're too. I don't know what it is about them. They're too something. I don't know.
I don't know. See, I don't like saisons. Saisons are like sour Belgians. I don't like them.
Well, there's like saisons. Yeah, I kind of like saisons.
Really?
Yeah.
They're like sour though. It's like
kind of crisp.
Make you pucker. I don't like the pucker when I drink beer.
If you're like an actual, I mean, I'm sure you've had like a sour beer.
Those are even worse.
I don't like those. I have a friend who loves them. Loves sour beers.
My
I just
dad
can't do
loves
them.
sours.
I don't get it.
And saisons.
It's not my thing.
Yeah.
It's just not my thing. Yeah.
No bueno.
But why is it called Trappist?
Why? Yeah. Why is the star system called Trappist?
Right. Go for it.
So, yeah. It's called Trappist because that's an acronym. Is that the right word? Mm-hmm. Yeah. It's called Trappist because it's an acronym. English major, yeah. Hey, not a major. I just got a minor in it.
Oh, English minor?
Yeah, German major. I would totally know it in German, I'm sure. But, yeah, so TRAPPIST stands for Transiting Planets and Planetesimals Small Telescope. It's the name of the telescope that first discovered exoplanets around this star and, first discovered this star.
Right. Additional information about this was provided by a space telescope called Spitzer.
Yeah, Spitzer.
We should mention a lot of the data for these kinds of things is provided by usually by more than one source.
Yeah, anything that you're discovering in the night sky, anything that major observatories are discovering in the night sky is confirmed and also collaborated with other big observatories. Yep. Spitzer is part of NASA. That's a NASA space program. Whereas TRAPPIST is a Belgian space program located in Chile. So there's a lot of collaboration with the sky. It's
Belgian? I didn't know it was Belgian.
It's Belgian. Yeah, we should have been drinking Belgians. Yeah,
of course they called it TRAPPIST.
So there's a lot of collaboration with astronomy, which is why it's such a great science, because it requires the cooperation of multiple cultures and peoples.
I don't know if I read... I might be wrong here, disclaimer, but I'm pretty sure that the Very Large Telescope had something to do with it too. They might have provided some data from the Very Large Telescope. Which is a great name for a telescope. The Very Large Telescope
at Paranal, is that how you pronounce that?
I don't know.
Yeah. So Paranal, it's Cerro Paranal. It's the mountain in northern Chile. So you've got a couple places in Chile that are participating. Yeah. Go Chile.
Chile.
Because you're so underdeveloped that you have a clear night sky. Great.
Right. So yeah, that's
TRAPPIST system.
TRAPPIST, the TRAPPIST-1. So a little bit about another thing about exoplanets is the naming convention. There's so many stars out there that some of them don't get cool names. So TRAPPIST-1 got a cool name. You have like Alpha Centauri, Alpha Proxima has a cool name. But all of these, the naming convention for the exoplanets goes by letters. So the star itself, it would be A. So in this case, TRAPPIST-1, A is the star that all these planets going around.
Yeah.
The first planet closest to it, assuming they're all discovered at the same time. The first planet closest to it would be TRAPPIST 1b, then C, D, E, F, G, and H.
So wait, assuming they're discovered at the same time, does that mean if you discovered like the furthest away planet first, you'd call it TRAPPIST B?
You would call it TRAPPIST B, yeah.
Interesting. So it prioritizes discovery time rather than proximity.
Yeah.
And it just so are all these based on proximity rather than discover time?
These ones are because they were all discovered at the same time.
Well, I thought because TRAPPIST, the TRAPPIST telescope in Belgium figured this stuff out a little while before NASA became a part of this. So originally you had 4 planets discovered by the TRAPPIST telescope, and then, that's kind of redundant, the TRAPPIST telescope. And then NASA discovered 3 more after the fact. So they weren't really discovered at the same time, maybe in the span of a year or two. But
I mean, that might be close enough for them to just say, to rearrange it, before
to correct themselves before the press takes a hold of it.
Before the press release, yeah.
And everyone's so familiar with calling them TRAPPIST A, B, C, and D, and
right, yeah.
Now we have to change it? What?
Yeah.
Though there have been... So, NASA asked... you remember when there was, a ship that people... in the UK where they ask people on the internet, hey, name this ship.
Bodie McBoatface.
Yeah, let's call it Bodie McBoatface.
Yeah.
NASA, did the same thing, hey, internet, what should we call these 7 planets? And they got things like the 7 dwarves, or 7 of the Party of 9 for Lord of the Rings, or the 7 lords of, what was it? It's the 7 lords of men, right, in the Lord of the Rings?
No, it's 9.
Who got the rings? 9 lords of men?
It's
and 7
dwarves.
dwarves. 7 dwarves, yeah. Are
Is
you
it?
sure? Wasn't it 5 dwarves?
Oh, shit, I don't remember.
Shoot, I don't remember either. So anyway, back to the 7 exoplanets. They've been named all sorts of things, from the 7 dwarves to 7 of the characters from Lord of the Rings. I don't remember which ones.
I heard them referred to as the 7 wonders of the TRAPPIST system.
Oh, that's cute. That's cute. Yeah, or the 7 Horcruxes, that sort of thing. All sorts of cute stuff.
Pshaw. Don't name it after the Horcruxes.
No bueno. So those are these new exoplanets, and they're so exciting because they are in a habitable zone, they're relatively close by, and, relatively, 40 light years. Remember, 800,000 years for us to get there.
It's 235 trillion miles.
That's a lot.
I remember that number. I didn't just do the math in my head.
Yeah, thank you. I was intimidated for a split second.
Don't be.
I think 40 light years is a good thing to remember. Simple. 4 and a 0.
Yeah.
Technically, it's only 39 and a half. I'll say that again. But 40. 40 is easy.
For sure.
So the reason it would take 800,000 years, that's assuming that we're using the rockets that are currently in space. Imagine Voyager 1 and Juno. Those probes are going about 14 kilometers a second. A little over that. So that's what we're thinking about, because those are the 2 probes that are actually closest to outside our solar system.
Right. They've been accelerating for a long time.
Voyager 1, though, is headed to... Shoot. It's headed to, I think, the closest star to us.
Alpha Proxima?
Is it Proxima or Centauri? I think you're right. No, Proxima, because it's
so
proximate.
Named because Proxima.
Yeah. And I was looking at
4
that.
4 light years away. I think that one is 4 light years away.
Yeah. But it should get there in a shit long time.
Shit long.
And the thing is, it'll make it within 1.5 light years of that star, of that system.
Of what? Proxima?
Yeah.
Oh, okay.
Which, when you think about it, is so far away. Who's going to discover a probe that small, that far away, if anything's over there?
Yeah.
Do we have a hard time keeping track of the comets and asteroids in our own solar system? How are we going to figure out if there's a probe within 2 light years? Crap, man. Do you think it'll still be broadcasting radio signals at that point? I doubt it.
I was gonna say, it may be just screaming. It's pretty much just screaming all the way there, isn't it?
I don't know. While it was targeted at Earth, it could still communicate with us, and it could still send and receive data, but once it got beyond that, what's the point of it sending or receiving data? Like, I don't even know. Is it still sending data to us? Do we know that those are still working on it?
I don't know. I don't know.
It's got the little plate on it from
The
that
record?
Carl Sagan worked on. Yeah, the record.
Yeah, that's right.
Yeah.
Yeah. Oh, it's got some other stuff too, some photographs and stuff like that.
Yeah. Does it have a blood sample, or am I just thinking of Doctor Who at this point?
I don't know if it has a blood sample. That
Okay.
seems outside though. V'ger?
V'ger?
Have you ever seen the... Oh, God, what is it? It's a Star Trek movie.
I haven't seen any Star Trek movies except the ones that have come out in the last 5 years.
It's one of the Star Trek movies. There's like an AI entity that I don't remember exactly because I've either never seen it or it's been a long time since I've seen it. But it's like a hyper intelligence, and they discover that it's Voyager, that it gains sentience.
Oh, that's kind of weird.
I don't remember exactly which one it is, but
A hyper-intelligence that's a Voyager and gains sentience. Where did Voyager get the means to
it just been
increase
I don't
its
know.
neural pathways?
Yeah, I don't know. It had just been out there for a long time or something like that.
You know, put a human out there for a long time and it'll just die. I think that's more likely.
Oh, this is Star Trek, so
Yeah. Yeah, they go above and beyond sometimes.
you should watch some of the Star Trek movies. I haven't seen them all, I'll be honest, but I have seen Journey Home, aka Save the Whales. It's a good one.
Oh, I didn't know about that one.
It's set in 1985.
Aww.
It's really good. It's really good. You should watch it.
Now, you say it's set in 1985. Was it made before or after 1985?
I think made and set in 1985.
Oh,
There's
okay.
time travel involved.
How could it be set in 1985 if there was star travel?
Time travel.
Time travel.
They go back to
Gotcha.
1985.
Gotcha.
Yeah.
I wouldn't, but, kudos to them.
But didn't love the 80s, right?
Yeah. Due to, all the pathogens they carried by the time they had star travel and going back to 1985, they probably wiped out civilization, but it's neither here nor there.
They were inoculated. You got Scotty. Or not Scotty. You got Bones.
Bones. Wait, isn't Bones the name of, a doctor show nowadays?
I think it's like a forensic...
Yeah. I wonder if they took that from Star Trek.
No, I think it's literally about bones.
Oh. That would make sense. That would make more
Bones
sense.
McCoy's, yeah.
It's not that original to come up with a doctor's name, Dr.
name is
Bones.
Bones? Well, his name isn't Bones, it's Leonard McCoy.
Leonard McCoy.
Leonard Bones McCoy.
Leonard McCoy. It's such a... Man, they came up with some good names
For sure.
for that.
I actually just watched the first one a little while ago. I should buy Beyond.
So, I was getting at it a little bit earlier, but there was a Voyager episode I saw recently that I thought was fucking horrible. What happened was, it was the first time that they managed to get to warp 10.
Yeah.
So they made it to warp 10, which is like infinite speed velocity. You can appear anywhere. It's like teleportation. Anywhere. And that raises some very interesting consequences, questions about humanity. It's such a deep topic to get into. But what they did with it is stupid as hell. So it turns out, if you try to go warp 10, you accelerate your evolutionary process and become a lizard. That was where they went with this episode. And what did they do with this episode? Well, the guy who went warp 10, who was slowly becoming a lizard, abducted the captain of the starship and forced her to go warp 10 so they'd both be lizards, and then they mated and had lizard babies on a planet somewhere in the Delta Quadrant. That was the whole plot of the episode. Even though they could have gone into the topic of, the existential crisis that is going at speed warp 10 and seeing all of existence, all of time and space in one moment. They didn't address that at all. Nor did they address the fact that he fucking abducted and raped the captain. None of that. Just disappointment all around.
I haven't seen it, so I can't say anything.
It's bad. It's bad. Have you seen Moana?
No, I
The
haven't.
new Disney movement?
No. We recently watched Arrival. Have you seen that?
No, what's that?
You know what? I'm not going to tell you anything about it. Just watch it.
Is it in theaters, or is it something I'll have to look up on Netflix?
It might be. It came out recently. It's got Amy Adams, Forrest Whitaker, and Jeremy Renner.
Okay.
So, We got it on Redbox, so I know it's on Redbox.
If it's on Redbox, okay, yeah.
Yeah, grab it. Don't look at anything. Don't try to
Arrival.
figure out what it is. Don't look at the
Arrival.
covers.
Okay.
Just
So
get
there's a nice
Arrival.
twist in there.
Yeah.
Yeah.
I mean,
okay.
I'll tell you, it's a sci-fi,
I figured.
and it got nominated and won some awards. It's not very often that a sci-fi gets nominated for awards, so I was very
Didn't
excited.
Contact win some stuff? I might just be.
Like I said, not often.
I might just be prejudiced because I like Jodie Foster and I liked Carl Sagan, so Contact was an important movie for me.
Arrival has a very, very interesting premise, and you should watch it.
Okay,
And yeah,
I will. I will do so.
yeah.
So Moana, you should see. It's cute. You don't
We've got
have.
it. We've got it on hand. We can watch it.
You've got it on hand.
Yeah, on Vudu.
Okay, I was gonna
Good or
say
bad?
like you don't have to go see it in theaters, but it is a cute Disney movie. It's got some good music. The problem I have with Moana, and this is a personal preference, is that it wasn't dark enough.
Huh.
It could have been so much darker, and that would have given it more gravity. It would have made me care about the characters more. And I've had several people say, David, you just need to accept this as a children's movie.
And it is.
It is a children's movie, but I just want, morbid reality in my children's movies, I guess.
That's what you have Up for.
Oh, the first 10 minutes of that movie are perfect.
Let's break for trivia. What do you say?
Yep, and I gotta
Alright.
urinate.
Okay, go urinate. I'll go pour a trivia shot.
And I'll get a new beer.
And we're back.
We're back.
And right after the break, it's trivia time.
What?
Trivia time. So our shots to begin the show. I don't know if we told them everybody what it was. The shots to begin the show was just cracking. We're basically, our shots are just random liquor Eric has laying around his house.
For tonight, yeah.
But it's a lot of whiskey and bourbon, which David doesn't
I
like
hate.
usually. So we're gonna stray away. So we did Kraken at the top of the show. This right here is Buckeye vodka. It's from Ohio. Hence the name.
Yeah.
But it's vodka. It doesn't like
Go
it's
Ohio.
vodka. We should some tequila sometime. Oh, we've done tequila in the past.
Have we done tequila?
Yeah, a few times.
I don't remember doing tequila. Maybe that's the problem.
Well, nobody ever does once they do enough tequila, so we should do tequila sometime. But anyway, you got some vodka shots here, and it's trivia time. Quick blurb about trivia time. We ask each other questions. If you ask the question and the other person gets it wrong, they drink the shot. If they get it right, you drink the shot. So you might drink 0, 1, or 2 shots. Who's going to go first?
Rock, paper, scissors?
You went first last time, so I'll go first this time.
Okay.
All right.
Go for it.
We're talking about detecting planets
Okay.
and astronomy in general.
Astronomy in general.
We haven't quite mentioned it yet, and we will, though. But a lot of detecting these things comes down to a little bit of physics and physics, a branch of physics, I don't know if you can say, or maybe a technique called spectroscopy.
Yes. Super important in astronomy.
Yeah, and that brings up the point of spectral lines. And I want to ask you about a little film called Spectre.
Oh.
Which is a James Bond film, which you told me you didn't see, but I'll try to drop a heavy hit here.
Okay.
And so maybe viewers at home, I'll probably get this too.
The last James Bond film I saw was the poker playing one.
Casino Royale?
That's the one.
You haven't seen Skyfall?
Nope, I haven't seen Skyfall.
Oh, dude, Skyfall's good.
Like, I mean to see them. I've seen the other James Bond films, like all the ones before that. I've seen those. But I enjoyed Casino Royale. It's not like that gave me a bad experience and I don't want to see it others. It's just I haven't gotten around to it.
Well, get around to it, I guess.
So, yeah.
So in the film Spectre, the opening scene takes place in Mexico City. And it's a long panning shot of James Bond walking through a festival, a celebration, like a parade.
Okay.
He's wearing like a skeleton, is a suit. Or no, he's not. It's a suit, and he's wearing a mask, which is a skull.
Okay.
What are they celebrating?
Day of the Dead.
Yes, it is. Dia de los Muertos. Ah.
I dated a Spanish teacher for a long time.
You did?
I did.
Was it your Spanish teacher?
No, I never learned Spanish. I learned German. Du sollst das wissen.
You didn't learn any Spanish through all that?
¿Por qué no? Which is, why not? And I learned that because I was studying German in Germany, and there were some Spanish students studying Germany, and they were trying to get us to party, which we did. But that was their that was their phrase for everything. Like, why not take another drink? Why not down this bottle? Ha ha ha!
I think I'd like to know these
Dude,
people.
The Spanish party like no other people.
That I could probably.
It's ridiculous.
Yeah.
You know, like partying with the Spanish, I would end up skinny dipping in like the Elbe River in Germany at 6 a.m. after a night of drinking. But like, it was ridiculous. It's crazy. They keep going. They just don't stop. You ever hear that song? It was popular in Europe for a bit. It was like, when I went to Spain and I saw how the people party, I was like, what the fuck? It was a dance song, and it was just they just kept saying over and over again, "What the fuck?"
Europeans, man.
And it was about Spanish people partying.
Okay.
And completely legit. Anyway.
All right. So you got a question for me? I'm taking this one.
I did. So, we're talking about exoplanets. They're planets. There's this place in Toy Story called Planet Pizza. Now, Planet Pizza is a barcade in Toy Story, the original. But there was also a Pizza Planet. Sorry. There was also a Pizza Planet at Disney World. It was one of the restaurants you could go to at Disney World down in Florida. But last year, they renovated it. They changed it. It is no longer Pizza Planet. What is it? So, you can tell me what the name of it is, like what is it? Or you can tell me what fandom it comes from. Like, it's not Toy Story anymore, I'll tell you that. But what affiliation is it from?
Is it still a restaurant?
It is.
Okay.
In fact, it is still a pizzeria.
It's still a pizzeria.
That's not really a hint, though, I'm sorry.
Okay. Okay. In an attempt to make it brief, I will say that it follows Ratatouille.
It does not.
Damn it!
I'm sorry. It's the Muppets. Actually.
Muppets?
Yeah, it is now.
I didn't even know that was a Disney property.
I didn't either. Yeah, no, it's weird. It's now Pizza. Oh shoot! I lost it. Where is it? Disney World.
While we were looking that up, I'm gonna take this.
Muppets. Yeah, go for it. Sorry, Pizzerizzo. Pizzerizzo. I think it's supposed to be something to do with the Swedish chef.
But all he ever says is pork, pork, pork.
No, he says all sorts of stuff.
Oh, does he?
He just goes, meet the boy, the beast, that sort of cadence, you know?
Okay.
Which is how Swedish people sound to Germans. Just saying.
Is that so? I was reading this thing once. It was a question they posed on Reddit, and they were saying, you know how we say that Chinese people say ching ching tong or whatever. They're like, what do you have for Americans? And somebody wrote up there is like, we just say that Americans just say howdy, howdy, howdy.
Yeah. It was perfect. I say that all the time.
I love it. Howdy, howdy, howdy. Oh my god, that reminds me of a Toy Story when the shark is wearing Woody's hat.
That's where it's from. That's exactly where it's from. Yeah. Howdy, howdy, howdy. I'm Woody.
Jeez.
I do that all the time. If I'm wearing someone else's glasses or hat, or if I'm drinking someone else's beer, like anything, I will say that phrase.
Howdy, howdy, howdy.
Oh yeah.
All right. Well, you know what? You can bring us into the next topic. I'm gonna take these shots.
Go for it. You know, I'm really depressed that I'm not joining you because this isn't whiskey. I feel like it should have been since you're taking both of them. But yeah, I don't feel too bad because I am drinking Imperial ales right now, and they're larger bottles than yours have been thus far, except for the Rheingeist. That's pretty big.
Well, IPAs aren't exactly light on the alcohol, you know.
Well, let's see. So you've got a 5.7% right now.
That's almost kind of low. 4.
And the one you had before that was 5%. So the last two I've had have both been 10% or higher.
All right, that's fair.
So we'll be,
I don't know how fair.
We'll
Right. Shots of vodka, but
well,
fair enough, I guess.
By weight, I think it'll be all right.
Bringing it around. What's our next point of discussion here, David?
So, this is after trivia. This is where we get a little more technical.
That's true. After we've had some drinks.
Right.
Yes.
How do we discover exoplanets? We're talking about things billions and billions of miles away. So, how do we even see these things? How do we even measure? How do we even quantify what's in their atmosphere? We've said these are rocky planets. We've said they're habitable. How the hell do we know all that? And in astronomy, it all comes down to one thing: light, emission. And we're not just talking about light in terms of what we can see,
Visible light,
light and dark, visible light. We're talking about the whole spectra of energy that's emitted by a star, which includes gamma rays, X-rays, radio waves, everything.
Yeah.
And that's where we get to. So,
we as Earthlings have detectors and telescopes everywhere. Got them up in space. We got them on ground. Generally, the ones that are in space get the clearer picture because the ones on ground have a lot of things to fight through. They've got pollution from other radiation sources on Earth, light pollution. They've got the atmosphere to go through. That's a whole thing.
Imagine trying to look up at the stars in the middle of your nearest city and looking up at the stars in the middle of your nearest nowhere.
Right. Exactly.
Yeah.
The nearest nowhere. So, when there's this collection of tools that we have, we gather data from the universe around us, right? Mm-hmm. So, as it pertains to detecting planets specifically, we gather all this data, but it's a couple of techniques that we use. I say a couple. I mean, there's actually a lot. We're not going to cover all of them because there's tons of them.
There are some that work better than others,
several.
and yeah.
But there are some tools that we rely on, basically techniques that we use on the data that we recover to look for certain things. What we're talking about here is exoplanets. There's a couple that we use to detect things like exoplanets. So I'm gonna muster up the courage to take this shot.
Take it. So one of the ways that we detect exoplanets, and in fact the most common way, and the way that we detected the planets in TRAPPIST-1, is through the transit method. And you can see that in the name of TRAPPIST. Like the TRA of TRAPPIST stands for transit. And what that is the planet transits between the sun and the earth. Is that the right way to phrase that word?
Yeah.
So
it transit just means it moves between.
It moves between. And we see that with lunar eclipses. If the moon gets between the earth and the sun, then we have darkness in the middle of the day. So it's because the moon is between the sun and the earth. And this is what happens with these planets that we see. The planets will come between the star that they're neighboring and the Earth. Now, for the Earth, if the moon gets in the way of the sun, well, crap, it's blocking out all of the sun. It's really close by. But in terms of a planet 40 light years away, getting in between its star and us, the percentage of light that we see from that star might drop 2 or 3%.
I wanted to say this, but I was busy taking a shot.
Congrats! Well done on those 2 shots. I want to cheers you for that.
The technique is called transit photometry.
Photometry.
Yeah.
Photo being as in photos.
Light. Yeah.
It's light. It's what we're talking about.
By
the way, cheers me right now. Well done, sir.
Thank you, sir. Heavenly. But continue. Keep talking.
So, these planets transit between their star and the Earth, and we see a noticeable drop in the percentage of light we get from the star.
Right.
In terms of how we can determine whether that drop is because of one planet or several, that I don't know. Do you know how they determine? So, we determine that there's a planet between us and the star by the transit, by the decrease in light received from that star. But in this case, we've found 7 planets using this method on one star. How do we know it's not one planet going around really fast?
It's kind of part of transit photometry. It's a bit called I just had it written. It's transit timing variations. So basically, we know that there are several stars because orbits are generally...
Several planets.
I'm sorry, several planets.
Yeah.
Orbits are generally very periodic. They're regular in time. So the signals that we were getting from this particular star, from TRAPPIST 1, you would like bop, 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 right? You would get a whole bunch of little dits where you would see the brightness of the star decrease. And if you graph those out, if you map them out, you'll see that there are certain drops in the dimness that are very periodic, right? So think about like
Morse code.
Yeah. Well, no. More specifically, like think about like a drum set playing. You're playing a drum set. You're gonna hit, if you're playing like a regular beat, just right. You're gonna get like that hi-hat hit very regularly, and you get this a very specific period for it. Ta 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 ta. Right. You're gonna get that kick drum hit at a very specific point. It comes periodically. So for the TRAPPIST signal, for the TRAPPIST 1 system, we saw a bunch of dips, and some of them we were able to map out in very specific periods.
Yeah.
And so by kind of separating them from each other, we say, all right, this one comes very so often. This must be its own planet.
Yeah.
This one's coming at a different period, like.
Yeah. So we can see that by the percentage drop in the sunlight we see from this star. I say starlight. We can see from this star. We can tell that they're different planets because there's a difference in the drop that we see.
There's both a difference in the amount of light that drops down and a difference between the timing. So the timing is important to know that there's more than one object there, and then the amount that the light drops down gives us a little insight about the size, because a larger object's going to block more light, right? Yeah. So from that, we were able to actually kind of determine the relative size of these planets. That's how we know that a certain number of them are roughly Earth-sized. So yeah, that ties that all comes together with another technique we'll talk about later, but the transit photometry gives us a pretty good idea of the size of these planets.
An interesting thing to note there too is that the first 3 planets that we discovered in the system were discovered, quote unquote, in 2015. Now that is to say that at that point they had gathered enough data from these repeated interruptions in the star's sunlight to say there are three planets there. Yeah. And that requires enough cycles to say this cycle is different than that one. This reduction in the amount of light we see from the star is repeatable to this period. So it's not that they just started looking at it in 2015. They've been looking at it for a long, long time. It's just that they have enough data now to say this is a periodic thing that occurs, dropping the starlight's emission by a certain percent over a certain amount of time. We can say that there's a planet there.
Yeah. They pointed the Spitzer telescope at this system for, I think they collected about 500 hours worth of data. And the more transits you get, basically the more passerbys that you get, the more sure you can be of your data. And they said that the closest planet in this particular system passed by the sun every day and a half or something like that.
Really freaking quick.
Yeah, fast. And the furthest one had a really long orbit, like 1,000-something years. Actually, the orbit is only about 20 days.
Really?
Yeah. It's not
How would they have measured that?
I don't know.
Yeah, like, wow.
They said, well, I mean, they might have been able to ascertain it from some other measurement, but...
yeah. At that point, if they can get the orbital period of several other planets and then calculate how fast they're orbiting with the other gravity bodies in the system, they could probably infer that, well, there's another planet here at this location, and that's why we saw this dip in that one spot.
Yeah. So
here's the thing. So, Belgians originally discovered the project, and in celebrating the discovery, they celebrated with a round of Trappist beer.
Oh, they did?
They did.
That's good.
They literally did.
I'm glad. Here's another thing I want to mention while we're still on the topic of transit photometry. Mm-hmm. For these particular planets, they noticed that there were slight variations in the orbits of these planets. The reason for that is because they're so closely packed, they're so close together, that their mass began to affect the orbits of their nearby neighbors.
Yeah. Mm-hmm.
And so, by observing this and using careful calculation, this is like amazing to me. Like the measurements must be so precise for them to determine this. We said before that the amount that the light dips down below its regular brightness will give us insight into their size, the planet's size. Mm-hmm. But by using by measuring how much these orbits are being affected by the other planets, they've been able to ascertain their approximate mass.
Oh yeah.
And that's also, it's related to another detection technique. But since they know the size of the planets and their mass because of this little measurement that they've taken, how much they're affecting each other via gravity, they've been able to, if you have mass and you have volume and you have size or volume, you can determine something's density. And so they've come to a determination. That's how they determine that most or all of these planets are rocky. They're terrestrial
because they're dense enough for it.
Yeah.
Yeah.
That to me is like fucking black magic.
It's really
just
crazy,
math, but it's
to combine spectroscopy. Thank you. Like surgery, but spectrally.
Yeah, it's pretty amazing. It's pretty amazing.
Spectroscopy.
So
combine it with just gravity analysis. Gravity is great.
Yeah.
God forbid we ever get into a vacuum decay of the universe, because it'd be depressing.
But speaking of gravity, there's another technique that they use to find exoplanets. It's called radial velocity. But I think you and I probably just prefer to call it the wobble method.
Wobble method. I was going to say, it's the wobble method, right?
It's the wobble method. You want to talk a little about that?
Well, it's basically that you've got a planet close enough to the star that the star's orbit is actually wobbling back and forth because of the influence of a planet so nearby.
Right.
So the star will appear in the sky, sort of move back and forth a little bit. Mm-hmm. And so the star wobbles, and you can tell that because of that, there's a large mass near the star.
Yeah. For our own star, Jupiter affects it. The acceleration from Jupiter is 13 meters per second, because Jupiter's fucking massive.
Jupiter's huge.
From Earth, even though we're closer, it's like 13 centimeters per second or something like that. It's really tiny.
It's really funny to think, because I was reading another article at some point how if Jupiter had been like 1.1 or 1.2 times as massive as it was, the amount of gas that it has would have caused it to collapse into a star.
Uh-huh.
Like, Jupiter was almost our binary star for this solar system.
If it was a binary system, we likely wouldn't be here, I would think, since we're sitting right between the two.
I don't know. Jupiter's small enough and far enough away. Like, we're much closer to the sun than we are to Jupiter. Much closer. And Jupiter is much smaller than the sun.
That's true.
So we still would have been in the habitable zone, so to speak.
Yeah.
That's another thing we didn't clarify earlier. The habitable zone is where liquid water exists.
Right.
So you can't be too close to the star, or else you'll vaporize all the water. It'll be too hot. Mm-hmm. And you can't be too far away, or else it'll be too cold, and you just get ice. For life as we know to exist, the way we all function requires liquid water.
Yeah.
Liquid water is kind of redundant, but it requires water.
Liquid H2O, we'll see. So we were talking about the wobble,
Wobble
method,
method.
right? So the way that we detect the wobble method is based on another part of astronomy, and that's analyzing spectral lines. Right?
Yeah.
So spectral lines are you'll hear them commonly referred to as like a fingerprint of so and so, of such and such. Basically, what's going on is that a star, the processes that happen inside of stars, the fusion, all that stuff that's making energy, all that stuff that's putting out light, is going to put out a very specific set of wavelengths of light, depending on what's going on with that star. This is how we know that certain stars are burning what kind of fuel, or certain stars are made up of something.
And how we know how old these stars are, or what size they are.
How big they are, things like that.
And that's all part of another episode we'll have to do on the life cycle of stars.
But basically just know that like stars kind of have a fingerprint, right? They have a very specific spectral signal, as I would say. You know, signature. Yeah, signature is great. Yeah, they have a signature. So these signatures we can get if we look at a star and you measure that spectral signature, we get something very specific. But the planets that orbit it can affect that signature. So when a planet passes by it, it may affect the signature if it has, per se, maybe an atmosphere that has certain elements in it that would absorb some of that light. And so when that planet passes, boom, all of a sudden you get a different signature. And from that signature, you can tell what a planet is made of, like, or at least what its atmosphere is made of. And we do have instruments that are precise enough to kind of see that, which is amazing to me, that we can see that kind of thing happening. Right now, I don't think that they have any specific atmospheric data on the TRAPPIST-1 planets.
That's the next goal, is to find atmospheric composition of those planets, to search for oxygen, argon, those sorts of things.
I was reading the thing a little while ago. I was like, why is oxygen
so key to...
And somebody put out there the idea that oxygen is super volatile. If you think about it. It's not very stable by itself. It burns easily.
Yeah.
So, if a planet has an atmosphere full of oxygen, there's got to be something there that's
producing
making oxygen.
Yeah. Oh, that's a good point.
Yeah.
Huh.
Right?
I didn't think... Yeah.
Right?
I like it.
Yeah. So, spectroscopy, that's a very interesting bit of study there. But it's very important to astronomy. It tells us what's where, you know, like if we can get a spectral analysis from something, you can tell what it is. Spectral analysis, I mean, it's not limited to astronomy. Spectral analysis is everywhere here.
I mean, if you've ever done a high school experiment where you burned different materials and saw how they glowed different colors, that's spectral analysis.
Exactly, yeah. At its very base, it's because certain processes, whether it be burning some sort of element, or in our case, like fusion, puts out a very specific energy signature, and that's something we can measure. And when it changes, you know something fucky is going on. So that's basically. I mean, there's I don't know if we mentioned before. There's tons of ways to analyze the data that we get from these telescopes. There's tons of ways to determine exoplanets, but these are kind of the more popular ones.
Yeah.
The ones that have kind of yielded the most results.
Yeah. Because, these things are so far away.
Yeah.
We can't really
send a letter.
See them. Yeah, we can't send a letter.
Or probe.
That would take 800,000 years. But there are scenarios where we've seen planets, quote unquote, with direct imaging, which is to say that we've pointed telescopes at these stars and used certain methods to block the light from the stars and see if we can see any other reflective light coming out of that solar system. So that direct imaging can get us a picture of what objects are surrounding a relatively nearby star, but the problem is it's so hard to block out the light of something that's a pixel big.
Yeah.
And not anything within that pixel.
Yeah.
So that's why we use these more complicated methods.
Yeah.
To
Another one I want to talk about, just because it's cool. It's not particularly useful. It's useful. It's very useful, but I mean, it's not particularly common to use this technique. It's called gravitational microlensing, and I think that just gravitational lensing in itself is interesting because it's very, very it's deep science, which is what you're all here for, right? Gravitational microlensing is a technique in which you use, as it pertains to exoplanets. We're sitting here on Earth. We look at a star that's lined up behind another one. You can see how it might be difficult because, it's not very rare that one comes right after another.
Not very common?
It's I mean, in the grand scheme of things, that they're perfectly aligned.
Yeah. It's not very common.
Right, yeah. That's what I'm saying. So we have one light source, or one star that's behind another one. The one that's further away is called the source star. The one that's closer is called the lens star, and it's so called because the light from the source star, as it passes the lens star, gets curved, and it's called lensing because the lens star acts as almost like a lens and a camera lens. It focuses that light. We can use
bends the light back towards us.
Yeah, we can use other massive bodies in the universe to act as lenses to see further away objects, which is like, but, and it works because of quantum mechanics.
Because of Einstein's general relativity, honestly.
Yeah.
Yeah.
I'm sorry. It's not quantum mechanics. It's relativity. That gravity bends
light and space. Yeah.
And so, like, would we ever have arrived at that conclusion without that theoretical notion? I don't think so. Could we use it as a tool if we didn't know that we could?
Existed? I mean, like, could you use a telescope if you tried to look at it from like the horizontal direction? No, you've got to look through a very specific hole in the telescope to see.
It's one of those things that it's there's also another method for detecting exoplanets that relies on relativity, but I didn't get into it because it's not very common.
Yeah, they get more and more complicated as you go.
Yeah. But gravitational microlensing basically is we can look at a source star through a lens star. So that lens star focuses the light for us. But if that lens star has got a planet going around it, the gravitational effect of that planet going around will distort that image, or will change the signal that we get from the source star, and
ever so slightly.
Yeah, and that little tiny blip,
ever so slightly.
That little tiny blip is enough for us. Probably with a couple of methods.
And I mean, this is what's amazing, is that the change in the light we see from that star for this method is so minuscule.
Yeah.
But the way we can tell it's a planet is this orbital period. The Earth circles the sun every 365 days. If we're looking at this star constantly for years, and we see that every 100 days, it has the same exact change, the same exact blip in its spectral analysis.
Do you think that somewhere scientists are getting excited about Earth because we sit in the habitable zone of Zorbazorp 1 or something?
Oh, totally. Zorbazorp. We were talking about Rick and Morty earlier.
Oh, God, it's so good. Fuck you, John, you white guilt milk bread piece of shit. Give me my lasagna. Zorbazorp field.
Man, that'd be so cool. It's just, just statistically, to find another sentient race with the same technological prowess that we have is so astronomically low.
Prowess is a bit of a confident term.
It is. It is. So this is the thing, right? Oh shoot, I forget what paradox this is called, but it's considered a paradox that we Fermi, thank you. Fermi paradox. So why don't we see some sort of spectral signal that we recognized as intelligently made? Well, perhaps there's some event that intelligent species can't pass through. Maybe all intelligent species eventually get destroyed by North Korea by their own foolishness, let's call it. Atomic explosions on their own planet, or perhaps they get destroyed by gamma ray bursts at some point in their history. Why don't we see radio signals or some other light signal of a very obvious intelligently made origin in the sky? Because statistically, if there are as many planets as we project there are in the galaxy or in the universe, we shouldn't be the only species. We shouldn't be the only intelligent species.
No, we shouldn't be.
So that's the Fermi paradox. Why haven't we discovered other alien life, or why isn't there alien life out there? So there must be some huge boundaries that sentient life hits that cause it to die out. I forget where I was going with this.
I mean, maybe it's just, for all the science fiction we have, the speed of light seems like a pretty hard wall, right?
Yeah. The speed of light's really limiting. In the most fortuitous estimates, we populate the galaxy, but never further.
I mean, even populating the galaxy is quite a feat.
Oh, huge, enormous. Yeah.
I mean, to us right now, populating the solar system is quite a feat.
It's something I don't think we're going to do in our lifetime.
Yeah.
Populating, I mean,
yeah.
And there's also to consider what we've talked about earlier, the habitable zone. If we've got ourselves and Mars in the habitable zone, I don't even know if Mars is in the habitable zone, is it? I think it is. But that's the thing. We've got so few planets in our habitable zone of our star that to populate the galaxy would simply mean to occupy 1 or 2 planets.
Right. I hope that we get a manned mission to Mars in our lifetime.
I really hope so too.
It'll be a 1969 moment for us.
As a 72-year-old me, I will giggle to myself in glee, much to the chagrin of my grandchildren, when I see that on the news. Yeah. I mean on Reddit, because that's where news will come from in 50 years.
Yeah. All right. You got anything else to say about this? I think we're fucking deep, man. Getting them nice.
We did. This is crazy. We've gone into extraterrestrial life, planets from another sun. It's really cool stuff.
For sure. Have you ever done the outro before? Have I always done the outro? I feel like I've always done the outro.
You have always done the outro. Because I don't really remember it. You want me to go for it?
You go for it, man. Try it.
Well, you guys, thanks for listening. We appreciate it. Don't forget to subscribe on iTunes, like us on Facebook, subscribe on YouTube. Check us out on Instagram, Twitter. We're all over the place. We've even got a Reddit account. Check that out. Gin and Jargon.
The username?
Yep, that's the username.
Maybe we should be mods of our own subreddit then.
That'd be cute. That'd be very cute. I don't think our Reddit username has done anything yet besides exist.
Yeah.
Which is a feat in and of itself, considering our current topic. Go us.
That's true.
So, give us some shot suggestions on Twitter. Tweet us at Gin and Jargon. And we would very much appreciate it, because I'm sick of drinking whiskey and rum, and Eric doesn't want to take gin shots. So
nobody shoots gin. It's
just a vindictive thing by me for everyone else who shoots other things.
Why? Why would you do that to us?
Because life should be bitter sometimes.
Just not
like
bitter.
Reality.
It's just gross to shoot.
Also, check us out at our website, ginandjargon.com.
Yes.
We will keep you up to date with the most recent episodes through all our other media outlets as well.
We'll try to get this episode out in less
A
than
timely
a
manner.
month's time or something.
Yeah.
But yeah, well done. Good job for the outro.
Sweet. Thank
Some
you, sir.
charisma, yeah.
Cheers.